Hello. In this video, we're going to take a look at a few more examples of integration by parts. This example is using the fact that we now have a definite integral. And what do we do with the bounds when we have a definite integral? We know the integration by parts formula, u dv is equal to u times v minus the integral of v du. We want to identify a u, to identify a dv. Going down our list, inverse trig. There's no inverse trig here. Second is L, logarithmic. We have the natural log of x. There is u. We're going to take the derivative of that to get du. And v is everything else. The only thing left is the dx, making dv equal to dx. So when we integrate, we'll get v equals x. And taking the derivative of u, we get 1 over x dx. Filling in our formula, the integral from 1 to e of the natural log of x dx is equal to u times v minus the integral of v times du. But we have a definite integral, meaning this integral still has those same bounds. And this part that we've already found piece of the antiderivative of is going to be evaluated on those bounds. So from 1 to e. We could evaluate that right now and find that piece to just be e, or we can save it till the end and evaluate everything at once at the end. I'm going to save it till the end. Now, that means we have x ln of x evaluated from 1 to e minus x times 1 over x is just 1, so we will have the integral of 1 dx. The integral of 1 is x, making the whole piece x ln of x minus x from 1 to e. If this integral had required u sub, then we may have different bounds on the two different pieces. But as long as we are just using integration by parts and no u sub, all the bounds stay the same of that 1 to e. Plugging in our bounds, we get e natural log of e minus e minus 1 natural log of 1 minus 1. E natural log of e is e minus the natural log of 1 is 0, giving this whole expression evaluating out to just 1. Now, natural log problems, really nice. With integration by parts, so we're going to take a look at another natural log using I late, and we're picking u and dv. U, very likely, if there's a natural log, going to be the natural log, making du 1 over x dx, and dv is everything else, the x cubed dx. We're going to integrate that. And be careful, we are integrating, not taking the derivative. So the integral of x cubed is 1/4 x to the 4th. Put that into our formula of u times v, 1/4 x to the 4th natural log of x, minus the integral of v du, 1/4 x to the fourth times 1 over x dx. X to the fourth times 1 over x is x cubed, making this line 1/4 x to the fourth natural log of x minus the integral of 1/4 x cubed dx. We can integrate x cubed. We already did integrate x cubed. It became 1/4 x to the fourth, making this whole line 1/4 x to the fourth natural log of x minus 1/16 from 1/4 times 1/4 x to the fourth plus c. And there, using integration by parts, is our integral of x cubed natural log of x dx.